All right, we'll go ahead and get started. So this class that I'll be teaching, I'm Alvie Griffith, I'm from Bentley, will be the FDOT GEOPAK Drainage class, and we will be doing the FDOT GEOPAK Drainage for Design. If you flip over to your first page in our book, that is going to cover chapters 1 through 11, and then chapters 15 through 19. We will probably skip chapter 15, which is culverts. You won't do a lot of that, but then we will do 16, 17, 18, and 19. So last time we covered all the plan preparation portions, and that means we probably will not need to use some of the VBAs that we ran into a few hiccups with last time. And since all of you have taken this class before, we'll be able to move fairly quickly because we do repeat some of the chapters that we did earlier. So the chapters that we'll cover is we're going to cover chapter 1, which is just a general getting started chapter. That's going to let us get into and activate drainage, make sure everything's working. Chapter 2, we'll review our drainage library, and then we'll go into project preferences. And once the project is all set up here at the end of chapter 3, then we'll actually be doing our design portion. We'll be doing drainage areas and nodes in chapter 4, the conveyance system or the pipes in chapter 5. We'll build our network in chapter 6, and then 7 will cover drainage profiles. 8 and 9 will really be our navigator and global editor and querying. Chapter 10 will be reports. And then in chapter 11, we're going to decide, or at least pretend we've decided, that we need to make some changes to our system, and we're going to add a couple of junction boxes and an inlet that'll go along with our system. Like I said, we'll probably skip chapter 15. Then 16 will be terrain models for designing or drainage design analysis. It's going to let us pick our areas and help us do that. 17 will be producing special ditch profiles. 18 will be pond design. And then finally 19 is importing stream geometric data to HEC-RAS. So to get started here, our data set is set up the same as before. And if you'll go ahead and open up that data set, we'll just extract the files at the beginning of each chapter that we have. Same thing we did last time. So I'm going to start here with chapter 1. That's going to have a 220 folder in there with the 1 in parentheses. If you'll dig in a little deeper, you'll find a 220 project with no parentheses, but it's the one that's ready for chapter 1. And from last time doing this, it seems like all of these are definitely set up and work fine to grab them at the beginning of each chapter and then just go ahead and go to work. Because we're not going to do every single step in every chapter. And even if we did, we probably would not do those all exactly the same. So this lets us start with a fresh data set with each chapter when we get into them. So I'm going to take this one. I don't know in these machines if drag or drop work better or copy and paste. Windows is sometimes a real pain about taking the folders out of zip files. But you'll want to put this, if you have it, in an eProjects folder. These shouldn't have anything in eProjects at all because they were wiped clean, right?
Yeah, I don't think they have an E folder.
Not even an E folder? Okay. So if you'll create an eProjects folder, that's where we'll put that 220 file. If you're ever actually teaching this or working with it, especially if you go out to any of the districts, just first thing right away have them go into eProjects and just delete everything out of there. There's usually all kinds of mess in the district folders on the training machines. And everything uses this, as you all know, the 220 project. So I'm going to go ahead and actually I'm going to make a backup copy of my project here in case we need some other files or something later. So I'm just going to rename this to old. Let's rename it to old FDOT Drainage. So you'll grab that 220 project folder. If you don't see it with at least a little bit of a progress bar, it didn't copy all the files. We ran into that a few times last time. If you go into the folder, it should have all of the folder structure that you're used to seeing. Usually if it doesn't extract all the files, what it'll do is it'll end up with just the meta info folders. That's usually what I've ran into. And then we'll go ahead here in chapter 1. And this manual is definitely written around the plan preparation manual, the drainage manual, and the CAD manual. So most everything that you'll see in here should be following the correct Florida DOT standards for the most part. There may have been some changes from when this manual was written, but probably not anything that's too significant because unfortunately drainage does not get near as much attention as the roadway standards. So to get started, if you'll flip to page 1-2, these should all be numbered with chapter number dash page number. And I realize some of this is review from the previous class. So the files that we're going to need are called project components. And there's a whole section in our project preferences that we'll set up to go along with those project components. The main file here, and they're all listed in bold with bullet points, is this GEOPAK drainage file. Has a .gdf extension, stands for GEOPAK drainage file. That's your database for the drainage system. So if you're backing up files or choosing which files to back up, that's definitely one of the ones you want to keep. That would be the equivalent to, in an older GEOPAK roadway project, the GPK file, where all the geometry is stored. So that's the main file that we'll be opening and using is the GEOPAK drainage file. And of course, the next file here, microstation design file, that's typically a DGN file, but there's no reason this would not also work with a DWG file. Haven't ever tried it with a DWG file, mainly because the class is not set up for that, but it should work with a DWG file also. And the next part is the drainage library. This is the piece that took lots and lots of time to set up. This is going to have all of the inlets, all of the junction boxes, slotted drains, all of the different pipe sizes. This is your main database for the different items that you're going to use in your drainage design. It includes the flow characteristics of the items, and it also includes the plan, profile, and cross-section views of those items. And it connects to the next file listed here, which is the drainage cell library, in order to get those plan, profile, and cross-section views of those elements. In addition to that, down at the bottom here, page 1-2, you have your Design and Computation Manager database. That is used later in the design workflow in order to get the elements to show up with the proper FDOT CADD standards and also with the appropriate tags for doing automated quantities. So as we're working through drainage and doing our design, we can pick any level, color, line weight, and style that we want to for our nodes and for our pipes and for our areas, just so that they're easy to see and easy to work with. And then later in the process, we'll update those nodes, pipes, and areas to follow the Design and Computation Manager database standards, which are pretty much for drainage, it's all brown. So it's not real easy to work with and easy to spot items. And then as we go over to the top of 1.3, you've got your geometry database. That's typically in your roadway folder. So we will have a roadway project, and it's going to point out there to the GPK file. That's going to contain all of our roadway geometry, and the main thing we're usually looking for is our alignments. So that GPK file is going to contain our alignments. And then the last section here, really in this class, since this is not doing the plans preparation portion, it's not really using many of these criteria files, if any. So some of the drainage items are drawn with VBA. Some of the drainage items are still drawn with criteria files, which is an older GEOPAK programming language. So we probably won't end up using those, but anytime you're doing plan preparation in GEOPAK drainage, you will end up using criteria files. That helps us draw some items that we have. This screenshot we have here in the middle of 1.3 There's a large portion at the top that's missing. These two arrows that are pointing up and down, basically right now pointing to the criteria file paragraph, there really should be at the top there a DGN bucket of some type, because everything that we do in drainage is interacting with that DGN file. So this, for whatever reason, has always been missing that piece. But really at the top there should be a DGN bucket, and then going down the left-hand side, that DGN is interacting with the GDF file for our project preferences, our drainage features, and our GPK file. And then on your right-hand side, it's interacting with our drainage library file. That's what has all our settings and all our standards in it. The GDF file and the drainage library, you can see the arrow going left and right. They interact with each other in order to get and load the standards. And then off to the side here from the drainage library, you can see where it's accessing the drainage cell library to give us our plan profile and cross-section appearances. And then we also interact here on the left-hand side at the very bottom with the DNC Manager database. That also contains the criteria files for the cross-section view. Your drainage components here at the bottom of 1.3 are nodes. Those are inlets and manholes typically. Links, which are typically pipes for the most part. It could be a gutter or it could be a slotted drain. And then those nodes and links are all connected together in what we call a network. And on a good sized project, you're going to have multiple networks with GEOPAK drainage. And those networks in general are going to consist of inlets that are connected by pipes or links. And those inlets and those pipes or links go out to a single outfall, which is typically a pond. And you might have 5, 6, or 10 ponds on a project. GEOPAK drainage only supports outfall to a single node. You can't have multiple outfalls in GEOPAK drainage. A lot of the other Bentley tools, the SUDA, StormCAD, the Haystead tools, they do have some more sophistication. GEOPAK drainage it's really designed around roadway drainage, and in particular, it was designed around the way Florida DOT, at least at that time, was doing drainage. And then another set of components we have here are areas. We have to designate a certain area. That area receives a certain amount of rain, and then that area times the depth of the rain that hits that area determines how much we have going through an inlet. So each inlet or each node is going to have its own area assigned. That's going to let us calculate how much flow we have through that node, and that's going to let us calculate the link sizes or the pipe sizes. We also have profiles. The profile is a path connecting any two nodes or more nodes in the network. The profiles do draw graphically, and we do also have the option to have those profiles saved in the GPK file so they can be represented on a roadway set of plans. And we'll make sure to show you how to do that. If you flip over to 1.4, since this is our design class, we have this general design process for the storm drains. And you can see here it's steps 1 through 11. We're going to do just about all of this. We're going to have a new project file here in step 1. We're going to pick our inlet locations. We're going to define area to each node in step 3. We're going to link the inlets together with pipe segments. We'll create a network from those nodes and inlets, or nodes and pipes rather, here in step number 5. We'll use GEOPAK to design the system and make sure that we have the correct pipe sizes for our flows. We'll make sure the design meets the criteria, such as minimum flow, hydraulic grade line, etc. And then as needed, this will actually be chapter 11. We'll edit the system and we'll recompute the hydraulics and check again if the criteria is met. In step 8, when we get to chapter 11, we'll add a few pieces to our design. We also have the option here in step 9 to add J-structure bottoms. If we have some large or skewed pipes, we have a couple of nodes that we'll do that on. We can then print our storm drain tabulation form, and then step 11 is prepare drainage plan sheets. So this workflow that's shown here on page 1.4 is really covering what we're doing in this class, the design process, and the previous part that we did before with the plan preparation. Plan preparation is typically one of the last things we do here, which is the preparing in step 10 the storm drain tabulation form and preparing the drainage plan sheets. Also, cross sections are included in plan sheets, so it's not just plan view; it's plan view, profile view, and cross section view. There in step number 11. All right, so we'll go ahead. If you'll flip to 1.6, we'll go ahead and create our new drainage project, and we'll also go ahead and create a file that will hold all of our drainage elements. These all have the SS4 and all that's on these, so we're good to go there. All right, so if you'll go into either the FDOT SS4 folder or double click on the SS4 icon on your desktop, that's how you always want to go into files with a Florida DOT project, which all of y'all know this already. This is more for the recording than anything. You don't want to double click on any DGN files. That's typically going to get you maybe generic GEOPAK, maybe it would get generic microstation without any GEOPAK or open roads in it. You definitely don't want to go to the start menu and go to Bentley programs and open it up from there. You always want to use the FDOT 2004 icon, or excuse me, SS4 icon. That's a few years ago. So FDOT SS4 icon. Project-wise, I don't need that on my machine. Everything's local, so I'm going to cancel. Y'all may get a prompt about Vault. I know we ran into that a couple times last time, and I think Vault sat there for a little bit. Y'all had to shut that down or wait for it a little bit longer. And then your file that you want to open, it really doesn't matter which file you open. The book does not open a file. They use the Create Files tool directly from the FDOT SS4 folder. But there's really no reason to do that. We're going to be inside of Power GEOPAK anyway, so we'll go ahead and do it from our bar menu. So I'm just going to go into my eProjects 220 folder, and I'll go into drainage, and I'll just open up the existing drainage file, the DREXRD01 DGN file. If you want to make sure before you go in that you are using FDOT SS4, you'll see that icon sets the user to FDOT SS4, not worried about the project, and the interface here is FDOT SS4. So the user is primarily going to give you the correct FDOT standards. The interface is going to give you some of the custom FDOT tasks, and it's also going to give you that pink bar menu that y'all have. So I'm going to open up the existing drainage. And then you should end up with, after a few moments, this pink bar menu should open up. On your task side, if you start out at the top of the task menu, primarily we're going to be in the FDOT plans development task, and that's going to have our drainage plans, and that's going to have a lot of our drainage commands there. If you ever need to move this pink bar menu, you can move it wherever you want to by left clicking and dragging. If you right click on standard and hit save settings, it'll flash off and come back on, and it should stick in that position. And that's mainly for the recording. It's not a big time saver, but if every time you open a drawing you're having to move that bar menu around, it saves you a few seconds there. All right, so if you look over on page 1.7, we have this giant dialog box that we're going to open up to create files. There's two ways that you can get to this create file dialog, and one way is by going into underneath your task menu, the FDOT plans development. And if you go into roadway plans, the very first icon in there, create new file, will bring up that dialog box similar to what you see on 1.7. The other way that you can get to this dialog box from within Power GEOPAK is go to Actions and Create Files. And when you're using this pink bar menu, if you click on the command itself, it activates the command. If you click on the question mark or any of the buttons on the left-hand side, it's going to open up the help menu for that particular function. So now I'm looking at the help menu for Create Files in this case. It'll usually open it up within a web browser. And what will happen is a lot of people will kind of go down the left-hand side of that pink bar menu, and they just end up opening up a bunch of help files. They don't end up with any commands happening. And it's not obvious because all it does is open up the help file in a browser, and it doesn't just pop up or anything for them. So I'm going to go here under Actions, Create Files. And you can run this completely separately from Power GEOPAK. So one of the ideas here, I'm sure, is if you had someone that their main job is creating different files for the project, they don't need a full-blown copy of Power GEOPAK sitting on their machine. They can just go in this FDOT SS4 folder, run Create Files from there, and they've got the same exact dialog. So I don't think they would need full-blown Power GEOPAK on their machine. I'm not positive about that. But the thought process with this dialog is once we have it set up to point to the project, the workspace, and control file, we should be able to create any type of CAD file anyone at Florida DOT needs. It should go in the right project folder, it should use the right seed file, and it should have the right name for the file. So we're not looking up the name of that file in the CAD Production Criteria Handbook. So since these are new machines that you're working on, everything at the top is going to be blank. Is that correct? So what you'll do is you'll click on the Project Settings button on the right-hand side toward the top. And then you're going to pick from this little dialog that comes up, Select Active Project. And then from there, there's another dialog that comes up. You're going to click the Browse button on the right-hand side. And you only want to browse just into the top of the main project folder. No matter what discipline you're working in, you only want to, with this browse, you only want to pick and dig into the top main project folder. So when you open up, when you go to E-Projects, you want to just double click on 220, and then you'll see all the DOT folder structure there. And then what you'll do is you'll click Select. It'll take you back to the Select Active Project dialog box and fill out that path. You're going to click OK there. Then you'll be back at the Project Settings dialog, and you'll click OK there. And that should fill out the project portion, and it should fill out the workspace portion. It should say FDOT SS4 for the workspace. I don't think it'll fill out the control file part yet for you. So for your control file, you'll have to click that pull down arrow, and I think it'll default to Geotech control. So you'll hit that pull down arrow and you'll pick roadway.ctl. Excuse me. What the control file controls is what options you get to pick from in the file group section. So when I pick roadway control, that loads up all these different file groups that we have for roadway. And what you'll want to pick is drainage design files from the file group. And what the file group controls is what shows up in the file type section here in the middle of this dialog box. And what we want to pick, and this dialog box is a little different than the book, it has a description or a discipline over on the left-hand side. So it'll look a little different, but we still want to pick the one that has drainage structures proposed here. So it's going to, if you click on it, it's going to fill out the name down at the bottom of the dialog for the output file, And it also fills out the folder and what seed file to use and so on. So it's going to try and create a file called drprrd01. If there was already a file out there, it would automatically increment to 0203. It won't accidentally overwrite any file. So what we're going to do is we're going to click now the Create button. Computer's going to beep. You'll click OK. And then you should be able to click Open File. And you might get a message about unable to access the feature database. That may only be on my computer.
No, I got it.
Okay. So on the unable to access feature database, just click OK. It's going to take you into this file. And as part of that tool, it should force you to set the plot scale as soon as it goes into that file. So we're going to set the plot scale to 50. And it should default to units, English units. So it has English metric, and I don't think you'll ever use unknown. Unknown is, I don't know what it is, so I don't know how the heck you'd use the file, but we'll set it to scale of 50, units will be English. And if we go ahead and click OK, we're in our file, everything's good. We can close this big dialog box. If you ever need to get back to the set plot scale portion, it's this little gold star over here on that pink bar menu. That'll take you right to set and update plot scale. And you'll probably, even though we're doing the open roads and other stuff now and using annotation scale, you're probably going to need to set that plot scale still, because some items are getting their size and scale from the plot scale of the drawing. Some are getting it from the annotation scale, and there's probably some other ways things are getting their sizing in the drawings. Not everything is based on the annotation scale right now. Excuse me. So that's got you a brand new blank empty file. Nothing in it. If you hit Fit View, down at the bottom left, it's going to tell you there's no elements found. Excuse me. So there's nothing in the file, nothing referenced in the file, just a plain empty blank slate here. And then if you flip over to 1.8, we'll go ahead and open up GEOPAK Drainage here. And there's two ways that we can do this. The way that's shown in the book here in step 1 on page 1.4 is to go up to GEOPAK, and then you can go to Drainage and then Drainage. That's also where you can get to the drainage help file. Now in the book, this book was written when Florida DOT was running MicroStation with GEOPAK on top of it. And when you were doing that, there was an applications menu inside of MicroStation, and it was not GEOPAK, it was applications, and then GEOPAK, and then all the different GEOPAK products. In this Power GEOPAK that we have, there's not an applications menu. It just goes straight to GEOPAK, and then you can go straight to GEOPAK Drainage. And if you click Help, of course, you get the GEOPAK Drainage help file. And if you click Drainage, you'll get the GEOPAK bar menu to open up for drainage. The other way of opening drainage here is to go into your FDOT Plans Development, go into Drainage Plans, and click the first icon in that task. That would also open up GEOPAK Drainage. So if you're teaching this to someone, probably the easiest thing to do is just take them out to task, point them to FDOT Plans Development, and then just open up Drainage Plans. That's going to give them most of the stuff that they'll need. So that's going to open up drainage here. You'll see a little bar menu. It's going to look just like what we have here on 1.8. It's going to say Drainage Untitled. Basically, there's no drainage project right now. And it's going to say there's no active network. You can dock this drainage tool here. I wouldn't recommend it, because when you dock the tool, it strips off the top part of this dialog box. So if you run into issues, sometimes it'll just bounce you out of the project. If you ever see it go back to drainage untitled and you know you were in a drainage project a moment ago, you know that you got bounced out of the project for some reason. If you just park this thing, you don't know. You don't get that indicator at the top as to what project you're in, if any. So I never dock it. I just leave it floating out here. You can, whatever you want to choose is perfectly fine. And then we do have, or are going to create, a brand new drainage file here in step 2. We're going to go to the main menu on drainage, and we're going to pick project new. This is going to default to the roadway folder probably. If you go up one level, that's going to put you at CE projects 220 and all the other numbers. And you'll go into drainage, and you're going to create a GDF file called SR61. So SR61 is the main line in this roadway project that has been created, or actually realigned. Something that you're going to have in the workflow that's in this class you probably wouldn't have on a real project is all of the roadway stuff is already absolutely done right now. So we're building this drainage project after the fact, after all the roadway design's been done. That's probably not going to be the case in the districts or in a real project. You're going to be doing drainage in conjunction alongside of the roadway project. So that's a big difference in the workflow we're simulating here. So we'll go ahead and create us a new GDF file called SR61. You'll see now the top of that menu for drainage changed. Now it says drainage SR61.gdf. So now that's created and we can use it. You'll also see underneath step 3 here that we do have this drainage toolbox and a set of icons. So if you click on the menu from drainage under toolboxes, there's a main toolbox which has all icons in it. And then there are separate toolboxes for project, area, node, link, profile, network, routing, culvert, reports, and utilities. You probably will very rarely use them, mainly because all of the books that you have use that main drainage menu. But they do the same thing. If I go here on the main drainage toolbox and I click on the first icon, which is drainage preferences, which is where we'll end up in a little bit, that's the same as clicking project preferences. I don't think you'll hardly ever use them. I don't think anyone you're trying to support or help out is going to use them either. Because all the books, everything I've seen is driven off of this main drainage menu here. Now maybe James, he's used drainage for quite a while. Worley. 2 James in class, Jameses. Maybe he uses the icons. I don't know. Well, when he gets here, we'll ask, but I kind of doubt it. So that finishes up chapter 1. We'll go ahead and get restarted here. Chapter 2 is going to be your drainage library. That's going to contain everything from these bullet points here, your rainfall data. We have land use runoff coefficients, where we can pick up that within our overall drainage area, we have a grass area, or we have an asphalt area, or we have some buildings. And as long as we use the correct symbology for those items, we'll be able to automatically delineate the runoff coefficient for those areas. This is also going to contain all of your nodes, your inlets, your junction boxes, your slotted drain. That's where a lot of the information, a lot of the work that goes in ahead of time of using GEOPAK drainage is in taking the very large design manual that we have at Florida DOT and getting all of those different nodes and all of the links as well, the pipes, into a database. That not only includes the hydraulic characteristics of those items, it includes the cells and how we want those items represented in plan, profile, and cross-section views. So we'll go ahead and get right to the exercise. and we'll take a look at the different drainage library items that you're going to see screenshots of that go from page 2.1 to 2.6. So the best way for us to review those sections is just to get in here and actually go ahead and look at our drainage library that we're going to be using. So we're still in. We really don't need to unzip the chapter 2 files, I don't think. We should be fine. So we're in the same drawing we were in a moment ago. We have the SR61 GDF file that we had already created. And then we're here on page 2.7, and we're going to go ahead and open up our drainage library. So to do that, step 1, we're going to go into Project, and we're going to go to Drainage Library. Now, since we're in the FDOT SS4 workspace, it should point to either a server. It's going to be different depending on your installation. But all the machines here in the room, they should point to the C drive. But typically this drainage library, it's pointing to a read-only file that's out on the server. If we want to save a local copy of it because we have some particular reason that we needed to create our own node, or we needed to modify a link, or we wanted to modify the land use items, we'd want to save that in the drainage folder of our project if we did have a reason to make a change to the drainage library. In general, you should not have that need. You should be able to use the one that's right out of the FDOT SS4 installation. So since we're in the FDOT workspace, you should not have to do this second step here, which is going to File, Open, and then browse out to this location here in step number 3. You probably won't ever have to do that. Whether you're working on these machines or you're working on your production machines, it's just going to go out there and grab the correct drainage library. Where you might have to do that is if you did make a change to your drainage library and saved a local copy of it in your project drainage folder. Every time you reopen the drawing, you're going to have to go, and it's going to point to the drainage library out on the CAD server or wherever the read-only file is. So every time you reopen, you'll have to do a File, Open, and then browse to your drainage library that you've maybe modified and saved in your drainage folder. So we can see this one's pointing to, these will all be local in this room. And it has everything here on your rainfall tab. It has your different zones. So we end up picking zone 1 for this one. Let's say that data was updated. If you double click on any of these items, this is where you're putting in the IDF curves or modifying the IDF curves for that particular zone. So all of these have a storm frequency, 2, 3, 5, 10, 25, and 50. And these are the IDF curves from historical rainfall data in those particular Florida DOT's drainage zones. I believe in the drainage manual, or somewhere out there, probably in the drainage manual, there's a map as to which different drainage zones that you have. It's probably in your drainage manual. So we're picking zone 1, and you can see if you double click on that, or if you click the icon on the right hand side that looks like 2 little pieces of paper, that'll also get you into modifying that particular zone. If you had a custom IDF curve, maybe for that project that you're working on, if you click the first little piece of paper icon on the right hand side, that'll let you make a new zone that will show up in your drainage library. If you're doing that, that's where you would really want to be sure that you did a file save as and you saved it out in your drainage folder of your project. Because what you're going to find out is even when these files are saved out on a CAD server and they're read-only somewhere, GEOPAK Drainage will still let you go through all the motions and let you look like you are saving or you are updating or adding a new zone. and then you go back and reopen that, it doesn't save anything. So if you are making any changes to this, make sure you save a copy on your local machine. So that's where our rainfall information is stored. If you click on the Land Use tab, we'll go ahead and take a look at that. And that's over here on page 28. There's only one set of land use. It says land use, it says FDOT standard or STD land use items. And if you were to double click on that, this is where we can have areas within our overall drainage areas that go to the inlets. And as long as we match the symbology such as level grass, building residential 2, building, pavement miscellaneous, building residential, and driveway, or any other ones that you want to add to your own project database, whatever areas within our drainage areas match these levels, they get a particular runoff coefficient assigned to them. So for example, if we have a grass area within our main areas, it's going to use a runoff coefficient of 0.25. If we have this multifamily residential on the level building residential 2 within our overall areas, it's going to get a runoff coefficient of 0.7. And then the rest of them are here as well. And we'll see when we get to the point where we're actually building areas, we have an overall area default runoff coefficient that we can use. So if we have an area and none of these symbologies are found inside of that area, that entire area is just going to get a default runoff coefficient. Or if we have an area and it finds some of these areas within our overall area, they will get the appropriate runoff coefficient from the land use table. And then any area that's not part of one of these is going to get the default runoff coefficient. We'll see that when we get to the point where we're building and defining areas. So that's the land use section. The next section here is going to be the node section. So we'll go ahead and click on that. And that's going to have all of the different types of curbs, grates, slotted drain, curb and grates, junctions, outlet, other, bottom, head wall. So if you click on curb, it's going to have all of the different curb inlet types that you have at Florida DOT, or at least a good bit of them. If you click on grate, it's going to have all of the ditch bottom inlets. If you click on slotted drain, there's only 2 flavors. There's a 40-foot and a 20-foot. If you click on curb and grate, there's nothing. Junction is going to be different junction boxes and manholes. Outlet is going to be all of the different mitered end sections and all the different sizes with different pipe configurations. There's some elliptical. And I think toward the bottom there may be there's probably flared end sections in there somewhere too. Other's going to have some of the elliptical and some wing walls. Bottom are all the different bottoms for the inlets, curb inlets typically. And then finally all the different head walls. So this is where all the background work has went into creating this database. If I were to go back to junction, or I'll go back to curb here. Double click on one of the curbs. That curb has an item ID. It has the curb opening height, the length. It has all the information about that particular curb inlet. Double click on another inlet. It has all the information about that type of inlet. So somebody at some point in time went through the big thick design manual and plugged in all the information for these, including pay items. And at some point, plan view cells had to be created for all of these. So that's really where all the background work has happened here, is in setting up this drainage library. And then you'll see on the link section here, if you'll click on that tab, you have no arch shapes at Florida DOT. There's no boxes in here. Most everything will be circular, but you have to pick the material of concrete. I think you're going to find that all your pipes are reinforced concrete pipes as far as designing. There's no plastic, there's no steel. So when you pick circular for the shape, if you don't see a whole bunch of pipes listed here, make sure you set the material to concrete. And if we double click on one of those, all these parameters had to be set up for these pipes as well, just like it was for the nodes. So you're going to have circular, you're going to have elliptical, and really that's it. Those are the only two that you're going to have, and they're all going to be concrete. And then the spread section, you've got a standard lane plus auxiliary. Standard lane plus auxiliary. The auxiliary has a 3% slope here. And then there's a standard lane 2% slope. This is used to calculate the spread section. That's shown back here on page 2-4. And you could create your own if needed by clicking this first little piece of paper icon, Add Library Item. And you'll see that here on page 2.9. They happen to double click on this first one, or excuse me, the middle one here in the spread section. And that's where you'll see what width these have. So the spread section here, this middle one, has a standard lane plus auxiliary. And you'll see that for the standard lane, it has a width of 12 with a 2% cross slope. And then for the auxiliary lane, it has a width of 12 with a 3% cross slope. If you double clicked on just the standard lane, it's just a 12-foot lane with a 2% slope. And of course, it has the roughness built in. If you click on the first one, that one has a standard lane at actually has a 10-foot lane at a 2% slope. Oh, excuse me, that's the shoulder. So that one has a 12-foot lane with a 3% slope. Then it has a 10-foot shoulder, or excuse me, a 10-foot lane with a 2% slope. And then it has a, okay, excuse me, the shoulder, I don't think this one's correct, just glancing at it. Because it says for the name, it says standard lane plus auxiliary plus 10-foot shoulder. So the standard lane, I think one of these is wrong. It should be a 12-foot lane with a 2% slope. Then it should be an auxiliary 12-foot lane. Those usually have a 3% slope. And then that 12 probably needs to go with the 6%. That would be for your shoulder. So I think that first one's probably wrong there. Just glancing at it. Because it would be a standard lane, which usually has a 2% slope. The auxiliary lane would have a 3% slope. And then the 10-foot shoulder, that's the one that would have your 6% slope probably. Anyway, you can change these. If you do change or modify any of these on your actual projects, or you direct anyone you're helping out to do that, do make sure that they do a file save as and save a copy of it in their drainage folder. That's going to make their life a whole lot easier later. I don't have a way to simulate it here, but I know for a fact if this is hooked into a read-only file, it will let me go through all the motions of changing things. It'll even let me go through all the motions of doing a file save usually, and it's really not saving anything. So if you think you're going to tweak this and change this at all, just throw a copy of it in your drainage folder. That way it's there. Anyone that follows behind you can work with it and have access to it. And that would be the same for that'd be the same for anything that you make any tweaks or changes to. Save a copy of it, of whatever appropriate folder happens to be. All right, so that finishes up chapter 2 here. All we really did was go to project drainage library and made sure the correct Florida DOT drainage library is attached. It should be, and it's mainly already attached because we went in through the FDOT SS4 workspace. So that's another key reason to direct everyone that's using this to go right out there to the SS4 icon. Don't double click on files. Always use that SS4 icon to get into the DGN files. All right, so that's going to take us here to Chapter 3, which is our project preferences. These are all the project preferences for our particular project. So these are embedded within the project itself. And we don't really need the zip files for this. We'll probably extract the zip files once we get to Chapter 4. So we'll just go straight into Chapter 3 here. And what we'll do is we will jump right to page 3-17. So from page 3-1 up to 316 are all the different project preferences for drainage. The best way to look at those is to go through the exercise and look at all the different project preferences and set them for our project. Just the best way to do it. So if you'll take a look on page 317, yeah, so once we go through and set all these project preferences, we're gonna make sure to save a copy of them. The book, once you get to whatever our last page is with the project preferences, which is page 327, they use this command here, project export, and they export the preferences to an ASCII file. That's nice to have. It's a nice, easy text file that you can read, and you can glance at the preferences, and you can see what someone's project is set up to look like without having to open up GEOPAK Drainage. But it doesn't save a file that we can reload. We can't reload that ASCII file. So we'll add a little bit to the book so that we can go in and save that and retrieve it each time. Because as Todd said, we're going to need to load that once we get to where we're unzipping these files, because when they created the data set for this class, their drives and directories and settings don't necessarily match what we want to use. So what we'll do, just make sure you're in the SR61 GDF file. You'll see that across the top of the drainage menu bar. And then we're going to pick project preferences. And you will not have to do the steps on 317, just so that you know. So what's happening on 317, and I think all of our other chapters that follow, is we're going to see a set of steps where we go through and access the GEOPAK Project Manager, so that we can make sure that drainage ends up pointing to the right GPK file for us. But what we're going to find out is when we get into and start setting these drainage preferences, we've got a shortcut to the user preferences anyway. So we're going to skip 317 and we're going to skip 318. So what you're going to see, just to walk through it, at the beginning of all these chapters that follow, you're going to see that they go through the steps of going to GEOPAK Road. They go into the GEOPAK Project Manager. They go and open up this SR61 Drainage PRJ file. They pick the user of student. And then that takes them here to page 318. Takes them to this big road project dialog box that they end up just minimizing, and then they go into and start accessing and working with GEOPAK Drainage. We definitely proved it last time. You don't have to go through any of those steps. The reason they're going through those steps here on page 317 and 318 is to make sure that they're pointed to the correct GEOPAK GPK file. But what we're going to see is that when we start going through our project preferences, on the second pull down here, project components, there's a button here that says user preferences. That takes us here where we could reset or check and make sure we're going to be able to pick up the right GPK file. So we're going to skip the whole GEOPAK project manager part on all the following chapters that have it. So on page 317, we're not doing that. 318, we're not doing that. We're going here on 319 and just going right into drainage. So where you should be is we're in the SR61 drainage file. And then from there, we're going to pick project preferences. You may get this missing or invalid rainfall item message that will come up. If you don't, that's fine. If you do get that message, just click OK. And then we'll start out here right literally at the first section, which is shown at the top of page 320, which is the units. So this GEOPAK GDF file, it doesn't really have units embedded into it. It's sort of like the GPK file. The GPK file itself, it has all the geometry, it excuse me, has all the names of points, the names of curves, the names of alignments. This has the names of nodes, the names of areas, all the parameters of the GEOPAK drainage system, but it doesn't really have as part of that GDF file what units that file is supposed to be in. So we have to tell it how to interpret that file or how we want that file's units to be assigned. And the way we do that is we just click one of these toggles here for either English or metric. So English, I think you'll see, is toggled by default, and that's what we want to have anyway. So the drainage areas, they're going to be defined in acres. The length is going to be in feet. The dimension is going to be in feet. The depth is in feet. Discharge is cubic feet per second. Velocity is feet per second. And then the intensity of rainfall is in inches per hour. So there really should not be anything excuse me, for us to do on that unit section. We should be good to go there. On the next part, which is our project components, this is where most of the work in the preferences is going to happen. All right, so project components, the drainage library, that should probably already be filled out for you. It should be local on all these machines. If you're out there online using a network perhaps, it might be a network drive. If you do think that you're going to make changes to your drainage library file, you might want to save a copy of it out there in your drainage folder. But we won't be making any changes to it. So generally, this drainage library file, it's either pointing to the FDOT 2004 folder, or it's pointing somewhere out on your CAD server typically. If you've made changes to that drainage library file, you would need to click the little magnifying glass to browse, and you would go up to your eProjects 220 folder, and you'd go into drainage and open up your drainage library file from there if you had tweaked or customized that file. So that part should be filled out for us. The next part is why you see that GEOPAK road, those couple of pages back on 317 and 318. If we click our magnifying glass next to the GEOPAK or GPK job number, you're going to see that there's two choices there. And the reason for that is the project was created in open roads, and the job 00 was some of the existing alignments, and the job 61 was some of the proposed alignments. So we have two GPK files. We want to pick this job 00.gpk. If those two choices for the GPK files don't show up, you'll want to click this button here, User Preferences. And this determines where GEOPAK Drainage is looking for that GPK file. So the working directory is probably pointing to roadway. That's where those two GPK files are stored. And that's typically where the GPK files are stored at Florida DOT. There is a little gotcha here on this User Preferences dialog box. And this is particular to what your machine might be set to. But if you click on the COGO Preferences button, there's another path where we can specifically say the GPK directory is in some other directory. So this path here on the COGO Preferences, it overrides the working directory. So if you're clicking that magnifying glass at any particular time and it's not showing the GPK file that you want to pick, you can't just click on User Preferences and stop here at the working directory. You want to go in and you want to click on COGO Preferences, and usually you want to make sure that job GPK directory there is blank. Because if it's not, here's what will happen. If I go and pick the, let's say, just the 220 folder, click OK. Roadway here is where the GPK file is. I know that for a fact. Click OK here. Hit the little magnifying glass. Nothing. So you have to watch out for this directory here. Just leave that blank. This one's going to point to roadway. And now I should have my GPK files back. So we'll pick the job 00.gpk. The drainage cell library, you should not have to do anything there. That should be filled out for you automatically. It's pointing to, I think on all these machines would be the same as my machine. It should be pointing to C, FDOT SS4, of course it goes away, C, FDOT SS4 resources, cell, and then DR plan is the drainage plan view for our cells. The criteria directory, that's going to be blank. And you're going to need to click the magnifying glass just to the right of that. And you're going to browse and pick the folder that our drainage criteria files are in. Even though we're probably not using them in any of our chapters that we're going through, we'll go ahead and set it up anyway. So the folder for that should be the same on all these machines. Should be the FDOT SS4 folder. And then it should be under GEOPAK criteria. And you're going to see there's two folders for the criteria files. So it should be GEOPAK criteria, and you want to left click and pick drainage. Now this isn't letting you pick a file, it's just a folder. So you can't dig in further than the criteria drainage folder. It's not letting you pick a file, it's letting you pick a folder. So that folder should be FDOT SS4, then GEOPAK, and then criteria, and then drainage. And we'll go ahead and click OK to pick that folder. And then we'll need to pick our DDB file. So that's our Design and Computation Manager database. So we'll click on this magnifying glass, and this should also be in your FDOT SS4 folder, and then it should be GEOPAK, databases, and FDOT SS4.ddb. And we'll make sure that we save this file of all the preferences, so we don't have to go through and check these every single time that we switch chapters and extract one of the zip files. So this DNC Manager file, it's on the C drive, FDOT SS4, and then GEOPAK databases. Water and sewer project, we don't have one. Super elevation shapes file, even though they pick it in the book, I'm trying to think if we need it. Yeah, we'll go ahead and pick it. Go ahead and click the magnifying glass for the shapes file. And this should be in your roadway folder. And it's the cross-section file, rdxs rd01.dgn. And I don't know for sure that they've created shapes in this file, but what GEOPAK Drainage tries to do is it tries to read the cross slope for the shapes where the inlets are being placed. So if it's not a hard-coded 2 or 3%, it can get a better read out there. So we'll go ahead and pick that. So your shapes file is going to be your roadway folder, and it'll be the rdxs rd01 file. And then last, we're going to have the original ground and the design surface. You'll see that in step 12. Now I know they didn't go through all the settings, but I wanted to make sure we had it set up right. The original ground, the 10 file there, if you browse out and pick that, it's going to be in the survey folder. So you'll have to go up one from roadway and then into survey. And it's going to be this GDTM RD01.10 file. That's going to be the existing ground. And then for your design surface, that's going to be in the roadway folder, and it's this SR61 final.10. And this is where the workflow is a little different than you would have in a real project, because you're not going to have the final proposed roadway surface as you're designing the drainage, alongside the roadway portion. You're not going to probably aren't going to have just a completely finished product out there. You're going to have to coordinate with roadway to get that all along the way and get updates. In this case, roadway project's done. We're just grabbing the files here. So that file is going to be SR61 final.10. Click open. And that's going to fill out all the project component section. And that's the piece where we want to make sure that we save all these settings and can reload them, because it's kind of it's a few steps to go through. Your rainfall parameters, that's over here at the top of page 321. The rainfall source here is going to be zone 2. Let's make sure it's picking that up. When y'all go to rainfall parameters, rainfall source, you get none available, or you get your zones? Yeah. Yeah, I had that error. So let's look at my project components. That's the drainage library. Might just have to reload it. There we go. So you're going to pick zone 2, wherever. I have no idea where that is. Probably it's going to be in your drainage manual. Just for the heck of it. Let's see if I luck out here. FDOT.
So the project's down in Coachella County. So.
Oh yeah. So closer to my area. Drainage.
Actually, just south here.
Is it? Oh, I'm thinking of
Yeah, down the property over there.
About 35 minutes out.
Yeah. I thought I might luck out. Anyway, I didn't. So about 30 minutes south of here.
Mm-hmm.
All right. So that'll be zone 2. The only method used at Florida DOT for the roadway drainage design is the rational method: intensity, duration, frequency. So how much rain for how long? How often does that happen? Every 2 years, 5 years, 10, 50. The SCS method isn't used on any of the GEOPAK drainage design for Florida DOT. So we'll set our source as zone 2. I don't think it's going to force you to pick one of these radio buttons. It's not forcing me to pick one. You can pick any of them that you want to. We're not going to be using that anyway. But I did notice it did not, when this first came up, it didn't force me to pick one of these buttons. Y'all's may have came up already toggled on that first one, because I had to relink to that drainage library. But that SCS method, we won't be using that at all. And then as we kind of keep moving down the left-hand side of this, for your land use options, You don't need to do anything here. I used to think that you would click on multiple land use items, and you could build your own here, but you don't have to do anything here in order for this to link back to the drainage library zones that we were looking at. It'll find the grass ones, the residential building ones. You don't have to do anything here to get access to those. So there won't be anything there to do on that section. The frequency options here, which is step 15, we're going to be using 3-year initially, and you're going to leave that coefficient peaking factor at 1. The SCS portion, don't need to do anything there. We're not going to be using that. So you'll see a screenshot of that at the top of page 322. And then for our intensity options, our minimum time of concentration is going to be 10 minutes. And we're going to compute the intensity from the library rainfall data source. So if we maybe we didn't have any data, we didn't have a zone to pick, you could pick an absolute intensity. That's inches per hour, I believe, and you could plug in a number that you thought was accurate there. But you really shouldn't ever have to change it from this compute intensity from the library rainfall data source. That should be the only thing there. It looks like everything else is set up good. We're doing the pipe accumulation, uniform flow velocity, and then we can move now to the junction losses. So on the initial run, we'll disable all the junction loss computations. And design-wise, I think the thought behind that is your initial run is you would disable all the junction losses, which is going to give you probably the highest hydraulic grade line that you might have. And what you're looking for on the profiles is you're looking for that hydraulic grade line. It shouldn't ever go up above any of the structure elevations. If it does, you might be able to come in here and uncheck, use all the losses. That's going to, obviously knock down the velocity of the water that's going through the system. It might let you squeak by and get that hydraulic grade line down to where it needs to be. So for now, we'll just disable all the junction losses. Inlet options, and these are pretty easy here. That I think is going to be set correctly. The inlet bypass options is bypass is total discharge. Do not allow inlet bypass in-link discharges. And then for whatever reason, this default spread in value, it's 0.015 here. Per the drainage manual, it's supposed to be 0.016. It probably wouldn't make any real difference, but it's supposed to be 0.016. And then there's a check mark here for extending the super elevation shapes to the inlet at the shape slope. What that check mark means, what all that wording means is, if you've got an inlet and the super elevation shape doesn't quite go all the way out to that inlet, it'll just continue whatever slope that shape happens to be. That's what that means. And then some of these inlet bypass options, the link bypass flow option, there is a whole section in here in Chapter 20, the technical reference, and also the help manual goes through and explains what a lot of these options are. But I do know for a fact that this manual was written around what the settings are supposed to be for Florida DOT, so we're pretty safe to literally here go by the book. If you flip over to 324, we'll go ahead and set the node option. And this is mainly just letting us set what we want the name of our nodes to be. So our nodes are all going to start with S dash, and it's going to be S-1, 2, 3, 200, whatever we need it to be. And then it also has a minimum freeboard, which you'll usually see as 1 foot even, but this is going to be 1.125. And the reason for that is it's including the little drop on the gutter section. So you'll see there's kind of a big gray note here right in the middle of page 324. So they're adding the 1.5 inch gutter depression that's where they get the 0.125 from. So that's why it's not just straight out an even 1. And then next we'll move here to our link options. These are our pipes. Usually they're pipes. We call them links. We're going to give a starting name for each pipe of pipe dash. We're going to try and minimize depth of cover when it's designing. That's already going to be set for you. The elevation option, though, is not going to be at the hydraulic center. We want it to be at the actual link end, the actual end of the pipes. And we're going to design for maximum capacity. The link slope decimal, you want to set that to 2. If you leave that set to no rounding, when we end up displaying profiles and annotating items, we'll end up with pipe slopes like 2.3495%. So set that link slope decimal to 2. And then the link criteria file, you're going to need to click the magnifying glass. That should take you out to the drainage folder. That's the folder that we picked a few moments ago for our criteria files. And you want to pick this one called pipe.x. So whenever it's drawing a pipe in a profile view, what it's going to do is it's going to pull the pipe.x criteria file. That's going to tell it how to go ahead and draw that pipe in a profile view. And then the hydraulic grade line section, you're going to set it to, you probably won't have to do anything. You're going to set it to equal hydraulic grade line. And then just a couple more settings here as you move to step number 21. These are the profile options. We're going to call our profiles PRO dash. So profile 1, 2, 3. And then this check mark here on page 325 in the book isn't checked. But this check mark here, buried way down in here in the drainage preferences, is what lets you create COGO chains and profiles from your drainage profiles that you can use in roadway and get them onto a plan set. If you don't check this, create COGO chains and profiles, those profiles are just stuck in GEOPAK drainage. There's no way to get them over to roadway and get them onto some plan sheets. Unless I've taught this recently, I have to dig into here and remember where the heck that little check mark is. So that the book does not have that checked. If you're marking up your book at all, I usually just write right on top of the screenshot and put a little check mark right there on the screenshot on 325. And then for your plan symbology, this is the section that lets us override what the normal drainage plan symbology would be. So this is the section that lets us use whatever color, line weight, and style we want to use as we're designing, and then we can go ahead and update that later with the pay items and turn it all into some flavor of brown, which is almost every drainage level has a bi-level color of some color of brown, which is hard to work with as you're designing. So on this section here, what I usually do is I don't worry about the level too much, but I set the areas and the pipes and the ditches and culverts to different colors. And then I kind of do the same thing with the inlets. So I'll show you a couple little cheats here, which work anywhere in GEOPAK. So anywhere you have these line previews or the text previews in GEOPAK, these little tricks I'll show you will work. So I'm going to double click on areas first. And I'm going to set my areas to be red, and I'm going to make them kind of a dashed. And I usually pick a weight of like 3 or 4. You can pick anything you want. You can pick any level that you want. So I'm going to click OK, and you're going to see that little preview update. If you right-click over that preview, you can pick Copy, and then you can hover over the text where it says sample. If you right click on there, you can say paste, and then that text will match the settings for the line work. You might still want to double click on the text and not give it a weight of 4 if you picked a weight of 4, because at a weight of 4 it becomes almost unreadable. But that copy and paste lets you do a little cheat there. And then I'm going to double click on pipes. You can pick whatever colors you want. I usually make the pipes light blue. And then I right click and do a copy. Right click over the sample and do a paste. And I probably would set the line weight on the text to like a 1 if you want to. We do not have any ditches or culverts, so you can leave those alone if you want to. And then for your node cell symbology, I'm going to check on Set Node Cell Symbology. I'm going to double click on inlets. I think I'm going to make them orange with a weight of 3. And I'm going to copy that down to and paste into the junctions line work. So I'm going to copy inlets to junctions, and I'm going to copy it to outlets. That way you don't have to double click each time. And I'm going to do the same thing with the text. The text you probably do not want to have as a line weight of 3. But that copy and paste, that little trick, that'll work anywhere that GEOPAK is showing you a line preview and a text preview and letting you double click to set those. The other little tricks built in on this right click here is you can pick by element. If you've got some element out in the drawing that matches the symbology that you want to use there, you can just pick by element and go click on the element, and it'll read in that symbology. Main thing is you don't have to double click here every time and set things manually. So when we get to the area section, my areas should show up in red, my pipe should show up in light blue, and my inlets, junctions, and outlets are going to show up in orange. So you can work with whatever colors you want to work with that are good for you to work with design-wise. You're not stuck with just the actual end result, which is some version of brown all the time. This will just make it a lot easier to work with. And then the last two sections here are updates. You do not have to have this automatically update when you make changes to nodes or links or redesign the network. And there's a reasonable, there's reasons for not doing that. You may just be kind of playing around with a few what-if scenarios, and you're not wanting GEOPAK drainage to update automatically. Generally, you are. I mean, generally, that's part of the reason you're using the program. So you're going to see here that if we move nodes, we want to automatically update where the pipes are. If we redesign the network, we want to automatically update the area. If we redesign the network, we want to update the nodes, we want to update the links. If we redesign the network, we want our profiles to update automatically. And then if we edit the profile manually, we can actually move and graphically edit the profile. We want to update the network. So you're going to just check on all these. It's all going to be checked on. And then for save options, we want to automatically save the drainage updates. When we'll go ahead and automatically back up, and we'll auto save every 10 minutes. So I would take more advantage of these options than the book shows here on page 327. Now, while we're still in this dialog box, you'll see in the upper left-hand side there's a file menu. If you go ahead and click on the file menu, you can do a save as, and you'll want to put this file probably out on your desktop. So I'm doing a file save as, and I'm going to call this SR61, and the file is going to have a DPF extension. So it's going to have a DPF extension, stands for Drainage Preferences file, and you'll go ahead and hit save. This is the file that we'll load every time that we unzip some files and get into another chapter. So we won't ever have to go through these preferences again. What we'll do is we'll open up our project, we'll open up our preferences each time, and we'll pick File Open, and we'll go out to the desktop and open up that DPF file. We normally would just place it in the drainage folder, but when we unzip and extract the dataset files, we're going to delete that whole 220 folder that we have out there in eProjects every time. So we're gonna trash that whole folder. That's why I put it out on the desktop, or put it anywhere that's not in your project folder. Normally it would be in the drainage folder. So once you have saved that file, you can go ahead and click OK. You'll get the little swirly here for a moment. It's going to ask you about attaching the shapefile as a reference. Would you like to attach this file now? I'm just going to say no. You'll get a message about it did not attach it, and then you'll get the more normal message here. Drainage preferences have changed. Do you wish to store the changes? Yep. I'll go ahead and hit yes, and that's going to save our preferences. The last step here that you'll see at the bottom of page 327 is to go to Project Export, and you can export those preferences to ASCII. Now for that, you can just put it in your drainage folder. You'll call it SR61_prefs, and it'll have a DRP extension. And that, I don't like how the book kind of misleads you there. It kind of makes you think that because you exported the drainage preferences here, it kind of makes you think that that's going to be something that you can load up later. But it's not. It's just spitting out those preferences and putting them in a text file. I mean, that's not a bad idea. You could go through the text file, make sure your project was set to everything that's in that text file if someone had saved it out in your drainage folder. But by far, your best bet is the step we didn't show in the book, which was going here on the preferences and doing the file save as. That's the file that you can load back into the project and retrieve those preferences and not reinvent the wheel every time. All right, so that's the end of chapter 3. All right, sorry about that. We've got I had the microphone off here, so I'll just go over what we did just a moment ago here. So what we've done so far is really just we reopened our drprrd01 file. That file initially was completely blank, and we've referenced in these files here that are shown at the bottom of page 417. So sorry about that. We've got the microphone working again out there online. Should be good to go. So what we've done, just to review, is, and I'll go through everything just so everyone has it. We initially closed completely out of Power GEOPAK, and we went ahead and deleted the entire 220 project folder and went into our dataset folder and extracted the files for chapter 4. So we started out by replacing our files with these zip files from chapter 4. Once we did that, we went ahead back into FDOT SS4, and we went right back into our drprrd01 file. Now that file, when we initially reopened it, the chapter 4 file itself was completely empty, just like the one that we created a little bit ago. And as soon as we got into our file, we went ahead into the FDOT Plans Development task and clicked the first icon to reopen GEOPAK Drainage. Now, GEOPAK Drainage should remember our last used project. So if we click on the project menu, the last project that we've used is going to be down here at the bottom of our list. So it's in the same folder, same path. So if I pick that and reopen the drainage project, we'll get a little bit of a progress bar there. You might get some messages about the shapefile. We don't need to attach that shapefile as a reference. That now has open our SR61 GDF file. And then we went ahead, since our preferences didn't match, you probably would get a warning about the criteria files and the criteria file location. We went to project preferences. And instead of rebuilding and going through all of these different preference settings, we went ahead and did a file open. And this is why we saved our preference file out here on the desktop or some location other than our project folder. So we should just have to, or be able to, reload this preference file each time and then click OK. That should, every time we unzip the project, we can load that preference file and we should be in pretty good shape. So at this point, sorry about the microphone that was being off there, but at this point what we did is we extracted the Chapter 4 files, and then we went ahead and reopened our SR61 drainage file and reloaded or loaded our project preferences fresh. And then where that put us was really initially on page 416, but as we talked about earlier, we do not have to go through the GEOPAK project manager at all. We really don't have to go through those steps whenever we're seeing these steps in the book here. So we didn't need the bottom of 416. We did not need the top of page 417. So what we did is we went straight to step 7, which we really had already done. We had reopened our GEOPAK drainage project, and we had loaded the preferences. So then we went to our references, and we referenced in these files. I'll leave that up here. I realize most of you are caught up there. I'll leave this up for a moment, though. So we referenced in these files. The only one that we did not reference in the default model was for the alignment file, the ALGN RD_50. That's the only one that we didn't just flat out reference the default model. All right, so that should have everyone in the file we want to work in. GEOPAK drainage project is open. We've loaded up the preferences for GEOPAK drainage, and we've referenced in the files that we want to have. If it gets too crowded or you need to turn a file on or off for any reason, don't detach it. Just use the little check marks under display, and that'll let you turn on and off items that you need to turn on and off. If you need to take it to more detail than that, you can always use level display, and you can pick individual levels on each file. If you do that, I would recommend setting your level filters to either all levels, or if you scroll down to the bottom, pick used levels, and then that way as you're turning on and off levels, you're only seeing levels that are used. If they're not used, you don't care about them. There's nothing to turn on or off. All right, so sorry about the microphone being off there. I'll try and be better about watching that. All right, so we'll go ahead and get started here. So that puts us here really at the top of 418. And what we're going to have to do first is we're going to have to go ahead and put in a node because the nodes are configured to have an area assigned. So we'll go ahead and we'll make sure everything's working. Looks like we're good. All right, so we're going to put in a node here around station 702. And we'll just do a couple of the nodes and a couple of the areas. If we look over on page 425, there's a list of all the nodes and all the areas. Once we've done a couple of these, there's not really any need to do all of them. We don't want to take up that much time. So 700 is roughly the intersection. And we're going to end up putting our first inlet around 702. So here's 701. Here's 702 right here. So this first inlet, I believe, ends up right around here. We'll find out. We'll be able to see it in just a moment here. So to place this inlet, we're going to go to the main menu of GEOPAK Drainage. And we're going to pick Component, Node, and we're going to pick Add. And that's how we're going to add and edit and get to the initial components as of right now. Later, when we get to Chapter 8, I believe it is, we're going to see that there's a tool called Navigator, and it makes it easier to do some of these editing and adding steps. So we kind of show you the hardest way of doing it first, and then make it a little bit easier as we move along. But this isn't too bad. We just go to Component, and we go to Node, and we pick Add. So we've got to have a node before you can have an area, or at least we should. So it's going to say Add New Node, and it's going to default to that prefix that we had earlier in our preferences, S-, and it's just going to try and go to S-1. So we want to change that S-1 to S-200. And if you want to give it a description such as curb inlet, you can, or you can leave the description blank. Either way is perfectly fine. So I'm going to go ahead and click OK. And that's going to open up our node configuration properties dialog. Once we start having elements in our GEOPAK Drainage database, all the elements will have an option for window center and highlighting up at the top. And then to the right of window center and highlight, you're going to have these little tiny icons that let you ID an element. So if you don't know what it's named but it's on screen, you can click ID and you can click on that element, whether it's a node, an area, or a link, and it'll take you to that particular element. Next to that is an icon for adding another node, or it could be link, or it could be an area. You'll see that the dialogues are all very similar. There's a delete option. Then there's a rename option. And then finally, there's an edit area, which is only on the node configuration, which we'll get to use in a moment here. So our node type here, as we walk down the left-hand side of this details section, our node type is going to be a curb inlet. It's going to be on grade, and it happens to be the one that is already picked here, inlet curb 1. Now the book is showing inlet curb with no number next to it. I don't think you'll find that. I don't think that's a correct item. Inlet curb 1 ends up being the correct item. So there's a 1 on it, not just inlet curb. And then we're also going to put a node bottom that goes with it. So you'll check on node bottom. That's going to add a preview here of the node bottom. And you're going to put in a P bottom that has a 3.5 foot diameter. And the way you do that is you hit this pull down arrow by node bottom. And these will be listed with J bottoms first. And then as you scroll down, it'll switch to P bottoms. and then you'll see a description of them over to the right-hand side. So this is going to be a P-bottom 35 DIA, and you'll see to the right of that, the description is that's a P-bottom, and it has a 3.5 foot diameter. And then there's a button here just to the right, and it says Align. If you click on that Align button, we'll actually get to use it once we see this inlet on screen, but this lets you adjust the top and the bottom so they line up better. So if we find that as we place our inlet, the top and bottom cells don't line up really well, what we can do is we click this Align button, and we can either adjust the bottom, or we can adjust the top, or we can adjust the bottom. Basically what you do is you hit the adjust button until they line up, and you click OK and they'll line up. Ours should be okay, but we'll find out once we try and place it. So that has all our properties. Your properties are what type of inlet are we placing. The next section here, which is step number 5, is where are we placing it? What's the location? And there's actually a bunch of ways that you can place these. We're going to use a chain and a profile in placing this. So you're probably going to have to, or at least we want to see the chain and the profile. So you'll want to check on chain, and you'll want to check on profile, and your chain's going to be SR61, and your profile will be SR61_PR. And then there's actually a pretty big button here that says Station DP. If you click that button and you go out on screen, you're going to see the station and offset dynamically update. And what we're going to do, since we're given a particular station value here, we're going to type in the station in a moment. But we want our element here to be aligned with a microstation element. So you're going to see an alignment section here. It says align at point, or we can pick tangent to chain, tangent to element. We want to pick this option here, tangent to element. And then just to the right of that, and it shows it in the book here, but it's a little tiny icon. It says select MS alignment element. And you're going to click on that little tiny icon, and you're going to go left click on this EP. Happens to be on the left hand side of the road. You'll left click on it once to highlight it, and then you'll left click again to accept that element. So what should happen now when I hit this DP button or station DP button, it should be aligned with that edge of pavement. Now sometimes this tangent to element isn't the best option. You can see mine is really not rotated parallel to that element at all. So I'm going to pick tangent on element, and we'll try that one. So we'll select our edge of pavement here, click it once to highlight, click again to accept, and then try the station DP button. And maybe there's a number here, and there is. If you look up here, if it's not working right, make sure that plus angle is set to 0. So now we're getting closer here. So I'll go back to tangent to element, pick this edge of pavement, and then back to the station DP button. So it'll stay parallel to that. And then we have a station we'll be able to lock in here, which is 701 plus 90. So I'm going to go up here. I'm going to type the station 70190. You don't have to do the plus mark. You'll hit your tab key. That'll lock in that station. And then we can put in the offset. And since this is to the left, it's going to be minus 44.5. And that's going to put it in the correct location. If we were doing the other side of the road, we might have to check on this mirror node option. And what that does is it flips it. So it basically flips that cell. In this case, you don't have to mirror the node at all. So I'm just typing 70190, hitting tab, and I'm picking the offset. Once you type in the station and the offset, you don't want to go back and hit the station DP button again. Because as soon as if you do that and you go out on screen, it's doing what it's supposed to do, and it's moving that inlet around. If that happens, if you click on that station DP button again, and you want to bail out of this, just do a right click, and the inlet will preview right at that 70190, 44.5 feet over there. So that looks to be correct as far as our inlet goes here at the bottom of page 418. And then we have some other criteria that we can fill out for this node. So if you look at the top of 419, we're going to do the spread criteria. And that's going to ask us, where do we want to read the longitudinal slope source? If you click the pull down, you're going to read that from the reference PGL. So that's why back on location we have that profile. What this is doing on the spread criteria is if you went into GEOPAK COGO and you looked at the slope of that profile at 701 plus 90, the slope, longitudinal slope along that profile is going to be 0.397 if you went and looked at that. So it's pulling it right from the GPK file from roadway. And that's why we use that GPK file. Now for their spread source here, they go ahead and use from the reference 10 file. And what it does is it reads the proposed 10 file, starts out here at the center line, and then it basically everywhere this hits a triangle, it reads a width and a slope. So it's reading 9 feet, hits a triangle, it's 2% slope. 4 feet, it's 2%. 14 more, it's still 2%. 5 foot more and 5.94, it's all 2%. So it's going out and it's reading that proposed 10 file. You're welcome to use that. It'll appear a little different than the screenshot in the book, and that's fine. You're also welcome to try one of the library items, and this is back where we had the standard lane, the standard and auxiliary, and the standard and auxiliary. So we're going to end up overwriting this later with zip files, so you're welcome to use whatever you want here. I just want to show you how it works. So if you can't get that to work, you'll want to pick for the longitudinal slope source, pick the reference PGL. That should give you a 0.397. And then for the spread source, if you can't it won't let you pick reference 10, then just pick library item and use I probably would use the standard auxiliary lanes plus the shoulder. If you knew what it was, you could do user defined as well. You could probably pull it off of the typical section sheet. What it's trying to do, and you can build these manually if you had to. So if you pick the library item, it's saying, all right, I've got 10 feet at a 2% slope, I've got 12 feet at a 3% slope, and I've got another 12 at a 6%. If I pick the reference 10, if you're able to do that and get it to work, it's reading those triangles. So let me put this one back to the final here. Yeah, and really where it's reading this from on the spread criteria, when you're able to pick the reference 10, it's like you were looking at, John Mark, the elevations. It's reading it from that 10 file. Because I switched the one in preferences, and it didn't change anything here. But when I switched it here and went back, Instead of a 2% cross slope all the way through, I was getting all kinds of weird existing numbers. So where this spread criteria is reading on this reference 10 is not necessarily back here in the project preferences on the components. It's reading it from the elevation section, whatever this reference surface is set to. On your spread criteria, there are settings that you have here that will produce automatic warnings in our reports. And those settings are on the right-hand side, the minimum and maximum ponded width. So, pond width and pond depth. So your pond width is 7.5 feet, meaning that if the water ends up calculating a half of the lane width, which would be 6 plus the gutter, that's where the 7.5 feet is. And then it also, if we get any ponding at all, anything above 0, it's going to produce a warning in the calculations when we go through the calculations. And then here at the bottom of 419, under the elevation section, our reference surface is a 10 file, and it should be reading the SR61 final 10 file, just like we see here underneath step 2. The elevation source is going to be the reference 10, really not reference model. Node elevation is same as source. You should get a 34. We're going to match soffit, and then the minimum depth and the maximum depth is the envelope that it will place the node in as far as above or below the design surface. So it's got a minimum depth here of 3, and it'll adjust when it goes through the design process up to a maximum depth of 20. So that's what controls the minimum depth of cover, and also how the maximum depth that node would be placed at relative to that proposed 10 file. On the junction losses, what this will do, if you flip over to the top of 420, this allows you to specify different methods for calculating junction losses, or different junction losses for that particular node if needed. That is not usually going to be needed, because that's why we have that whole drainage library out there. So you're going to leave it toggled on, just like is shown in the book here, to defined equations. So you probably won't ever have to change any of that. And then for your discharge options, we're going to use the computed discharge. That won't change. And then on computations, when you click on that, you won't have anything. And that's because this node doesn't have an area assigned to it yet. Once the node has an area assigned to it, then it's going to go ahead and be able to produce some type of computations. So we'll go ahead and we're going to hit apply here. And that's going to store that inlet. And what we'll do is we'll assign an area to the inlet after lunch and create a couple more inlets. So just go ahead and hit apply on that inlet. If you want to just leave it on this screen here looking at that node, that's perfectly fine. We'll come back after lunch and hit page 421, and we'll start assigning areas to these different nodes, and we'll create a few more nodes. So that'll be our plan. All right, so I did not find out the problem with the areas yet, so we'll go and revisit that as we get time. So we're just picking the overall areas. And then a question came up here in class, what's the best way to get this to line up at the intersection of, here, at a particular location? Probably the best way to do that is back when we're looking at the node and doing an edit, is to use on the location tab this set by or station DP button. You can just say change the alignment to at point, And that should, if you uncheck everything, should make it pretty much attached to your cursor. It's going to attach at the center of the manhole. I don't think the command by itself supports snaps. So if you set that alignment to at point, John Mark, and then click the station DP button, let's say I wanted to put it right exactly here. You can see how it's not snapping. But if you hold down Control and Shift on your keyboard at the same time, it'll activate the snap options for you. There's a lot of Kogo tools that are like that, where you would really want to snap to something, but by default it doesn't let you snap. So if you hold down Control and Shift on your keyboard, then it'll activate the snapping option. That's the best way I can think of it. So it's not a particular station, it's not a particular offset, it's at the intersection of two or more lines. And the trick there is you have to set the alignment to at point, and then you also have to make sure that the offset part is unchecked as well. Because when I first fired that up, I had the offset checked on, and it just stayed locked in at that offset. Now I really think as soon as you pick alignment at point, it probably should just uncheck that for you. But that's going to let it float around, and then you can put it anywhere. All right, so to get started with Chapter 5 here, you'll want to make sure that you are completely out of Power GEOPAK, because we're going to go ahead and delete the whole 220 folder, and then we'll drag in a new 220 folder that represents the completed Chapter 4. So I'm going to go into my eProjects folder, and we'll go ahead. I'm going to delete the 220 folder, just the whole folder from there. And then from my drainage data set, I'm going to go into the data set folder, and we'll take our data set Chapter 5 files. First, double click on that zip file. You're going to see there's a 5 in parentheses next to the folder. And if you double click one more time, it should now take you into the Chapter 5 version or flavor of this project. And I'm just going to take that whole 220 project, and I'm just going to drag it over and put it into eProjects. If you don't get at least a little bit of a delay, a little bit of processing time there, it did not copy all the files, so you'll want to do that again. Usually you can tell by opening up the folder. If it has all of the typical Florida DOT directory structure in there, you're probably fine. It probably did copy and get all the files. Usually what happens if it does not get all the files, it tends to stop right at only getting the _ meta info folder that's out there. So it looks like we have all our files, and we'll go ahead and reopen FDOT SS4, and it should go ahead and remember the last file that we were in, which is our proposed drainage file. So we'll go ahead and reopen. Make sure you use the FDOT SS4 icon. Most of you probably have that as an option down in your quick start menu. And I won't be needing ProjectWise for this, so we'll cancel out of that. And we're just going to go right back into the drprrd01 file. I'll go ahead and click Open. This drawing will look a little bit different because what you're going to see in there is it's been rotated to read more directly left and right on the SR61. So it's been rotated differently than your previous drawing was. And then to get back into the drainage, we'll go ahead into the FDOT Plans Development task. That should have stuck and stayed from before. And then I'm going to go here into Drainage Plans, and we're going to hit that first icon to reopen GEOPAK Drainage. You'll get a little progress bar there. GEOPAK Drainage will go ahead and reopen. Or it may give me the option to show you another tool that we have in the FDOT SS4 folder. and that tool is called Clear Crash. If you ever have to, if the program crashes, if you have to bail out of the program, if you run into any issues such as you saw just then, run Clear Crash. That's going to go ahead and clear out any of the Power GEOPAK processes, and then you'll go ahead and restart it. And I'll make another attempt here at reopening GEOPAK Drainage. There we go. So that's going to open up GEOPAK Drainage. There won't be any active project. And if you'll pick project and go right down to the bottom there, that should reopen our SR61 GDF. You're going to get the criteria directory information. Just click OK to that. And we're getting that message because we need to go to Project Preferences, and we need to reopen by doing File Open from our desktop our Drainage Preferences file. Our directories don't match what the dataset directories do. And we can go ahead and click OK to Preferences. You may get a warning about the shapes file if yours is set up like mine. We don't need to attach it as a reference, and we will click Yes to save the preferences. Now what you're going to see excuse me, in our drawing is that the inlets and the areas, they are displayed with whatever color, line weight, and style generally matches the FDOT CADD standards at this point. If you want to refresh the drawing and make them match those colors that you picked earlier in the preferences, what you would do is you would go to the component menu, and you can pick component area, and you can pick update all. That's going to refresh all the areas with the color that we picked earlier. And then if you go back to component and pick node, we can say update all. That's going to make mine a little bit easier to spot text-wise as well as color-wise. And then now we'll be working with links in a moment. So since we haven't created any links yet, there's no need to update those, but those links should follow the color convention that we set up earlier in this plan symbology section of our preferences. So I've updated the areas to have that red dash line, and I've updated the nodes to have the orange color there. They're all on the default level. And then later, if we do some plan quantity computations, we'll be updating those elements, but the nodes and the links, it won't be just update all, it's going to be update with pay items. So there's an additional non-graphical piece that gets tagged to these elements, these links and nodes, so that they show up on plan quantity computations. So right now it's just symbology that's being updated. All right, so the conveyance system here in Chapter 5, the best way to look at this is go to our exercise. There is a good sketch here on 5.4 that you'll see at the bottom. It has your node elevation. It has that minimum depth setting that we talked about in the nodes configuration. And I'll put that on screen so will make a lot more sense. So back here on our nodes configuration on elevations, we had the minimum depth we had set to 3 feet. That's that top dimension here on this page 5-4. And then the maximum depth is this 20 feet that we had plugged in for our design computations. So the dashed lines you see here on 5-4, when we go in and actually compute the network tomorrow, that 3 to 20 feet in depth below our proposed terrain is going to be the envelope that GEOPAK Drainage is going to try and fit that node in, or that inlet in. And then the pipe nodes and elevations, that's all going to be calculated when we design the network. So we really won't have all of the information together and calculated until we create our network and analyze it tomorrow. Here on page 5.5, you do have some constraints. These constraints are allowing you to specify the minimum and maximum rise of the pipe or size of the pipe, allowing you to specify the minimum and maximum slope and the minimum and maximum velocity. Now, GEOPAK, if it needs to, it'll exceed the minimum and maximum sometimes, and it'll give you a warning about that when we compute and analyze the network. The only item here that tends to trip people up, and myself included, is the rise of the pipe. That is in units of feet. We tend to think of pipes in 18-inch, 24-inch, 30-inch pipes. This minimum and maximum rise, that's in units of feet. So this pipe here that's shown in the middle of page 5.5, the smallest size that would ever calculate and make the pipe would be 1.5 feet, so that's 18 inches. The biggest it would ever try and make this pipe would be 60 inches. And that's like the pipe envelope. That's the size range that the pipe can take as you analyze and process the system. If you look on page 5.7, we won't have to do steps 1 through, really we won't have to do anything on page 5.7. We don't have to do steps 1, 2, and 3, 4, and 5 because those are the GEOPAK road steps that links to the GPK file. We already saw how we can directly link to that and get around it. And we won't have to do step 6 and 7 because we've already opened our drainage project and already loaded the preferences. So what we will do is we're going to go through page 5.8 through 5.10. We'll enter one pipe and then leave everyone some time to enter the remaining pipes that we have shown here on page 5.10. So to get started with a brand new pipe, we're going to go up to our main menu here at the top of page 5.8. And we're going to go to Component, and we're going to pick Link, and we're going to pick Add. So previously, we had to have nodes before we could assign areas to those nodes. And we've got to have nodes before we can connect the nodes with pipes. We can't just have a random pipe sitting out there. It would draw it, it would maybe even store it, but it just wouldn't work quite right. So we're going to go here to Component Link Add. And because of our preferences, it's going to try and call this first one pipe-1. We gave it the preference of pipe- earlier. It's going to try and call it pipe-1, and we're going to change that to pipe-200. And then we'll go ahead and click OK. And then once again at the top of this dialog box for these items, you're going to see what looks like the other dialog boxes. It has options for clicking a pull down and picking the other available items. It has arrows left and right to go to the different items and window center and highlight them. And then it has icons for IDing an item, creating a new item, deleting an item, and also renaming an item. So I'll move this over to the side for a moment. And if you were to take a look, if you went to Component and you went to Node and picked Edit, you would see all the nodes that are now in this drainage project. So now if I window center and highlight, as I step back and forth to the different nodes, they're going to window center on my screen and highlight. It doesn't control the zoom, so if you're zoomed way out, it will still window center and highlight. It's just not going to be very useful to you. So I can zoom in so I can see any one of the nodes. And then as I step back and forth, I can see them window center and highlight pretty readily. Maybe the text is turned off in the file, and I don't know what this manhole here happens to be. I can click this first icon just to the right of window center and highlight, ID drainage node, go click on the node, and it'll take me right to that node and tell me what node that is. The pipes or the links and the areas work the same exact way. If I go into Component Area, Edit, top of the dialog box is virtually identical, and I can scroll back and forth and I can see it highlight the different areas. If I don't know what an area happens to be, I click the icon just to the right of window center and highlight, and it'll take me right to that area, whatever it happens to be. So pretty easy to navigate. There's some even better navigation tools that we'll run into tomorrow. All right, so back on our pipe, or our links is really the correct term, because it's not all pipes all the time. You're going to see, excuse me, on the left-hand side we have definition, conditions, constraints, and computation. We won't have any computation for the pipes until we build the network tomorrow morning. So we can fill out the other three though. So on the definition option, there's a few ways here that we can pick and choose which nodes these pipes or this link goes between. And you'll see that here in the book in steps 1 and 2. We can click the pull down for the from node. From node on this one's going to be S200. And then the to node is going to be S-201. And there's nothing wrong if you just hit apply, it'll go ahead and store a pipe here in between those two nodes. But what you're going to see is you're probably not going to like where the pipe itself connects if you do it that way. It wouldn't affect the network calculations. It would affect the length overall if we did a quantity computation on the pipe, but it wouldn't be something that would, break the whole system. But a better way to connect these nodes is what's shown here in step number 3. Just to the right of the from node and the to node are two little tiny icons. If you click on the icon, it'll let you pick the node. And these nodes, it's hard as heck to see, but they have little red dots around the edges. If you use that little tiny icon, you can click these dots around the edges and give it a more logical location where that pipe really would connect to the actual inlet. The little icons are hard to see, and the little red dots are hard to see. You don't have to snap to the little red dot, but if you just click near the red dot, it'll go ahead and connect that pipe in a more reasonable fashion. That's your better method here in step number 3 here on 5.8. Now for a time, you'll have both of the pipes shown on screen. So you'll have the one that was drawn previously when you clicked apply, and then you'll have a preview of the one that's about to be drawn. So it'll look like you have two pipes in there. If you hit apply, the previous one will go away, and then it'll go ahead and update and put in the new one. So the book, somehow they end up with 106.25 in length. I get 106 even if I pick the two dots on either side of these nodes. I get 106 even. The quarter of a foot, who cares? Doesn't really matter. The size of our pipe here that we're picking, you'll see that at the bottom of 5.8. We're picking a circular concrete pipe, and we'll go ahead and let it be an 18-inch pipe. And then some of the toggles we'll get to work with tomorrow morning is the design size toggle and then the design number of barrels. So when we do get into the design process, and this can be a little bit confusing, if design size is unchecked, it locks in and keeps the 18-inch size. If design barrels is unchecked, it does however many pipes that you pick in this pull down here. If we check on design size, that pipe size may change. If we check on design barrels, the number of barrels or number of pipes physically placed in there will change. And I have seen, and this is one of the reasons I'm leaving this for tomorrow morning, I have seen where we have design size checked on. We purposely pick a pipe that we know would be too small, and it doesn't always change it. It can be, it'll be a process we'll have to do a few times probably. So we'll leave everything unchecked at the bottom for now. And then when we get into the design portion, there is a tool in the network analysis that lets us, excuse me, lock and unlock all the sizes if needed, and lock and unlock all the barrels if needed. So if we have 20 pipes in our network, we don't have to scroll through there and lock and unlock things manually. That would be a royal pain. If we happen to have a DGN element that represents our pipe, and there could be, especially if it were an existing pipe, you can pick just a standard microstation DGN element. You check on Use Element, or Use MS Element, you click on ID, you double click on that microstation element, and then that'll be your pipe. It's not applicable in this case, but it might be where we're picking an existing pipe or something that we're tying into. So you do have that an option there. If you use that temporarily, you do get to go back and click those little tiny icons again, and then you'll hit apply again, and then that should put the pipe in the correct location here. So we'll pick 200 here, and we'll pick 201 over here. Many, many times I have picked the same node, and that's when this section here grays out. You can't go from the same node to the one node to the same node. I've done that a bunch of times. So whenever you click these ID buttons here, it does not only pick up that little red dot, it is picking up the location of that node and the name of the node. And we'll put this one right here in the middle, back where it was. And it's a little bit hard to see, but there are a whole bunch of those little red dots around the side here. So that may have been what happened in the book where they got that extra quarter foot of pipe happening there. If you pick this one here and this one over here, it should be 106 even. And then to look at the conditions for the pipe, if you click on conditions, it's going to show you what the minimum cover would be. So our minimum cover elevation on the from node would be 30.3, and then the to node would be 29.9, and it'll show the max depth. You are able to check and fix any of these values later once we go through the computation of the network, if we don't like what the network has computed. So these are all, anywhere you see a check mark in here, these are all overridable, if that's a word. So anything where you've got a check mark, you can override those options there. The last part we'll be able to fill out for right now is going to be the constraints here, which is step number 12 here on page 5.9. So we're saying here at the top, the rise of the pipe, even though we picked back on definition that's an 18-inch pipe, if we go in and we design the size, it's going to use anything from excuse me, an 18-inch pipe or 1.5 feet minimum, and it'll go up to 60-inch pipe maximum. If it exceeds the maximum, it's going to try and go in here. If we've checked design barrels, it should go in and try and put in more 60-inch pipes. Now that's not going to happen in this system at all. I think almost all of them stay at 18 inches in this system. And there's one pipe that goes to the outfall, I think is 30 or 36, if I remember correctly. So conditions, we're not going to add anything there. We'll just fill out the constraints. Our minimum slope is 0.15. These are in percentage. Maximum is 10%. And then velocity is in foot per second. These values should match the drainage manual. So in the drainage manual, it should say the minimum slope is 0.15%. It should say the maximum slope is 10%. I haven't checked that, haven't verified it, but these should match and should follow the correct Florida DOT standards. If you click on computation, that link's not part of a network. The two nodes are connected, but all the calculation hasn't happened yet in order for us to get all the computation on the pipes. That's going to happen in Chapter 6 tomorrow morning. So you'll go ahead and click Apply. And then what we'll do for the next probably 20 minutes or so, maybe a little bit longer, is we'll flip over to page 510. And I'll let you all go ahead and enter these additional pipes that we have on page 510. And I'll do the same thing. So go ahead and take about 20 minutes or so, and we'll enter these 12 more pipes. From time to time, you will get this warning, unable to create link graphic. You'll probably get that every time that you click this second icon here that lets you create a new pipe. Just click OK to that, because what happens is when you click Add Link, it defaults and it has the From node and the To node both being S200. So every time you're in that dialog box and you click the icon for adding a new pipe, you're going to get that message about can't create link graphic. So I think every time you hit that second little icon there, you'll probably get that message about can't create link graphic. Maybe you'll only get it one time, but you'll think you'll definitely hit it one time for sure. We're going to end up extracting Chapter 6 zip files in the morning. So if you want to be a little lazier on the configuration of these pipes and not click on the small icon and the little red dots, you're more than welcome to skip that. You can just pick the From node and the To node, and the pipe size should take care of it for all of them. What I would recommend is just pick the From node and To node, hit Apply, and then that's going to draw the pipe on your screen, and then use the little tiny icons to go ahead and connect everything up with those little red dots. So I would do it the real easy, quick way first, and then click the little icons and use the little red dots. If you're not sure where a pipe is, click the From and To nodes in the pull down, hit Apply, and then toggle off of it and back onto it. Use that window center and highlight. That way it'll jump right up on screen for you. In the long run, it won't matter, but they skip in the book on page 510 from pipe 203 up to pipe 206. I do not go in sequential order here. Won't matter in the long run because we're going to borrow the Chapter 6 zip files later anyway, but just a note there. So after you create pipe 203, they're jumping up to 206. The reason they're doing that is the typical naming convention on these is the pipe is one number higher than the From node. So this one goes from S205, so they're calling it pipe S206, or excuse me. All right, take a few more minutes and finish these up. If you're done already, I would go ahead and use the component link edit and go through and check and make sure they're all correct. All right, so hopefully everyone had enough time to wrap up these links or pipes. It's almost always pipes. And what we'll do here is, I did want to point out one thing before we kind of shut this down. I wanted to point out that since we did not do all the inlets individually, if you'll go to Component Node and go to Edit, we do have an inlet here. It should be, I think, it's called S211 out. And that one is the one that has a particular node type of outlet. So the way that GEOPAK drainage is set up is we can have as many networks as we would like to in order to cover this whole project. But the networks themselves are a group of inlets, a group of links, or usually pipes connecting those inlets, and they all go to a single outlet. And when we're building these networks, GEOPAK drainage, although you can get away with it at some point, you generally want to kind of build one network and process it, then go in and put all the pieces, the nodes, and the links for the next network with one outlet, then build the next one. When we get to Chapter 6 tomorrow morning, GEOPAK drainage doesn't really tend to like any straight inlets or links or manholes out there. It wants it all connected. And I think we might even run into, this is not obviously the Chapter 6 zip files, but I think we'll have this same kind of situation like we have here. So we have an S204 and a 206. They're not connected to anything. We're going to get some error messages and some warnings about that probably. Definitely, if we had a link between 204 and 206, we would definitely get an error message. It does not like stray pieces out there. It'll still build the network and it'll still work, but it really does not like to have those extra pieces out there. The reason they're out here is at some point, and I think it's going to be Chapter 11 for our revisions, we're going to come in and we're going to add a junction box and a ditch bottom inlet here. So we're going to add some pieces to this network, and they happen to already be placed in there. But in general, GEOPAK drainage wants you to build all the nodes for one particular network. I want you to go ahead and build all the links that connect those nodes, and all of the flow is going to go eventually to one node, and that node's going to have a particular setting on it that it's set to a node type of outlet. And GEOPAK drainage wants each network to have only one outlet. That's the only way that it works. You can't have it outlet to 2 ponds, 3 ponds, or whatever. It's all built around what you've probably seen on roadway plans typically. We've got a set of inlets, we've got a set of pipes, and then all the flow that goes through that system goes out into a pond somewhere. Then literally a little further down the road, more inlets, more pipes, that goes to another pond, then a third pond or whatever. So that's the general layout there.